Hello students, today we are going to see exercise 4.1, the remaining problems 9 to 13. Okay, previously we have seen 1 to 8, isn't it? So now we are going to see sums from 9 to 13. Sum number 9, how many 3-digit numbers which are divisible by 5 can be formed using the digits 0, 1, 2, 3, 4, 5 if repetition of digits are not allowed. Now, totally how many number of digits are there? So first we have to see that, and also you must keep one thing in mind: divisible by 5, isn't it? So divisible by 5 means number ends with 0 and 5 can be divisible by 5. That is very important. Now 6 digits are there, isn't it? 1, 2, 3, 4, 5, 6 digits. So total number of digits 6. So first we have to take two sets. What is the two sets means? We have 3 digits numbers, isn't it? You have to see 3 digit numbers. So 3 dashes I have given. Here also 3 dashes are given and R is given. The reason is I told that number ends with 0 or 5 can be divisible by 5. So that's why I have taken like this. So now see here, in this dash I'm going to place 5 and in this dash I'm going to place 0. So now I'll tell you the answer. Since we are going to place 5, only 1 can be placed here, only one number. Now here 0 cannot be placed because if I place 0, the number will be a 2-digit number. So I cannot place 0. It is told that repetition of digits not allowed. So totally 6 digits. Already one number is placed here. 0 cannot be included. So we have only 4 digits can be placed here. Now one number is placed here, isn't it? Now remaining 3 digits, but in this place 0 can be included. So 3 plus 1, 4 digits can be placed. Now coming this side, here 0 is placed, so only one number, that is 0 is placed here. So one possibility is here. Here 0 cannot be placed. So other than 0 we can place number like 1, 2, 3, 4, 5. So totally 5 possibilities. So one number is placed here now. So remaining 4 numbers can be placed. So here it is 4. Can you understand? Right. Now this one or this one. So you have to, or means you have to make an addition, isn't it? Previously I told the fundamental principle rule. Or means plus. So number of ways 3-digit numbers can be formed which are divisible by 5 is 4 into 4 into 1 plus 5 into 4 into 1, that is 16 plus 20, which is equal to 36. Second subdivision, repetition of digits are not allowed. Since repetition of digits are allowed, you don't want to take these two parts. You can take in a single part even and you can find the answer. So first we are going to place 0 or 5 here, isn't it? So two possibilities here, isn't it? 0 or 5, two possibilities. So any one of the two numbers like 0 or 5 is placed. So one number is placed here. So remaining we have 5 numbers, isn't it? So in this place we know that 0 cannot be included. Since repetition of digits allowed, we can place 0 to 5 any numbers, but 0 cannot be allowed. So we can place 1, 2, 3, 4 or 5. So 5 possibilities. Now in this place you can place any numbers from 0 to 5. So totally 6 possibilities. So number of ways 3-digit numbers formed which are divisible by 5 with repetition allowed is 5 into 6 into 2, which is 16. Sum 10. To travel from a place A to B, there are 2 bus routes. What are the 2 bus routes? That is B1, B2. Okay, B1 and B2 bus routes, and 2 air routes, which is T1, from here to here T1 and here to here T2, and two train routes T1, T2, and one air route, it's A1. In the same way, from B to C to travel, we have one bus route which is B dash and 2 different train routes which is T dash and T dash 1 and T dash 2, and one air route which is A dash 1. Now the question asked is find the number of ways the routes of commuting place A to C, from here to here via B, through B, but we cannot use the similar mode of transportation. For example, if I take bus routes in A to B means I cannot take bus routes here in B to C. Suppose if I take train route here means I cannot take the train route. So how to find the answer? So first of all, you see here, first I am going to take the bus route. So if I take bus route, so here two bus routes are there, isn't it? So A to B, I have taken the two bus routes, isn't it? A to B, there are two bus routes. Now coming to B to C, I cannot take the bus route. I can take train route or air route. So totally there are three. So 3 is placed here. Now suppose if I take train route for A to B, T1 and T2. So two train routes are there. Suppose the train routes here T1, T2 cannot be taken. So remaining B1, B-1 and A-1 can be taken. So that is also true. Then comes air route. So coming to air route, there is one air route for A to B. So I have put one here. Here B to C, I cannot take the air route. Right? So B-1, T-1, T-2. So totally 3. So R and R. So you have to make addition. So finally the answer to A to C is 2 into 3 plus 2 into 2 plus 1 into 3, which is 6 plus 4 plus 3, which is equal to 13. Sum 11. How many numbers are there between 1 to 1000, including 1 and 1000, which are divisible by neither by 2 nor by 5, not by 2 and not by 5? So first we have to see one digit number, then two digit number, then three digit number, then four digit number. So one digit number, so totally we have 10 digits, isn't it? So first one digit number. How to place the one digit number means you know that 1, 3, 5, 7, 9. These are the numbers can be divisible not by 2 and not by 5. So one digit number is totally 4. Coming to two digit number. Two digit number ending must be what? 1, 3, 7, 9 only. That is the only way. So last digits in the two digit number can be placed 4 ways, isn't it? Now here 0 cannot be included. So excluding 0, totally 9 digits, isn't it? Okay. Then 3 digit number, the same way we can do it. So 3 digit number, in this place I have to make what? 4, and in this place I have to make 10, isn't it? All the numbers can be included, but here 0 cannot be included, so it is 9. Okay, so some small adjustment you have to do it. Right, now 4 digit number. What is the 4 digit number? 1000 is 4 digit number. 1000 can be divisible by 2 and by 5, so we cannot include it. So totally we have to add all the values. So 4 plus 9 into 4 plus 9 into 10 into 4. Okay, so number of numbers from 1 to 1000 is what I have said so far, which is equal to 4 plus 36 plus 360, which is equal to 400. Sum 12. In how many ways can be how many strings can be formed using the letters LOTUS if the word either starts with L or ends with S? Okay, so first number of letters LOTUS is 5, isn't it? First I'm going to keep L, placing L in the beginning, and I'm going to find the number of strings. So since first place is occupied by L, it can be placed by one way. In second remaining we can use either O, T, U, S. So 4 letters. So 4, then 3, then 2, then 1. So totally we have 24 ways. Then placing S, that is ending with S. The same methodology will be followed. So here it is 1. So remaining 4, 3 and 2 and 1. Okay, right. So here also we have totally 24 letters. Now we have to keep one thing in mind. They have told that either start with S or start with L or end with S. Suppose if I take the first case, here it's starting with L. Suppose I put O, T, U, and this place I have put S, means it's starting with L and ending with S. So that's supposed not to be considered. Either L or ending with S. So this includes ending with S also. The same way here, this includes starting with L also. So that has to be removed first of all. So I am going to find letters starting with L and ending with S. So since starting with L means it is occupied by 1 and here ending with S, so this place is filled with one way. So remaining how many letters are there? 3, so then 2, then 1. So totally 6 ways. So these are the total ways. From this I have to subtract the 6, which is the required answer. So number of strings can be formed That is either start with L or S is equal to 24 plus 24 minus 6 is equal to 42. Subdivision 2 of the same question, neither start with L or end with S. So first we have to do the find the total number of letters formed using LOTUS without any restriction. So number of letters 5 without restriction means very simple. You know that first place is 5, second place is 4, 3, 2, 1. So totally we have 120. Now what I have to do is I have to subtract this from the previous answer. That is to find the number of strings formed neither starts with L nor with N nor ends with S means first previously we have found just now we have found the strings formed using without any restriction, which is what 120. Then strings can be formed with starting with L or S. Previously in previous first subdivision we have found the value is 42. So 120 minus 42, which is 78, which is the required answer. Then the last problem, count the total number of ways of answering 6 objective type questions. Each questions have 4 choices. Right? So now see here. So first question, second question, third question, fourth question, fifth question, sixth question. First question can be answered in 4 ways. Similarly, second question 4 ways, third question 4, 5 and 6. So finally what is the answer? Total number of ways of answering the objective question 6 is 4 into 4 into 4 6 times, so 4 to the power 6. So subdivision 2, in how many ways 10 pigeons can be placed in different pigeon holes? Okay, there are 3 pigeon holes are given. So first, how many pigeons are there? There are 10 pigeons, isn't it? P1, P2, P3 up to P10. So one pigeon hole is having 3 holes, pigeon holes. So either in first hole or second hole or in third hole the pigeon one can go through. So it is placed, it can be placed by 3 ways. Similarly for P2, P3 until P10 all the pigeons are having 3 different pigeon holes. So the final answer, the number of ways the 10 pigeons can be placed is 10 times. So 3 to the power 10. There is a subdivision 3, so that is left as homework. So, okay, do it as home assignment, very simple in the same procedure. So that's all, we are completing this statement problem. Remaining few sums, it is based on different concept that will be taught in the next class. That's all. Thank you.